Hello, everyone. My name is Andrew Mendoza. I am a technical recruiter at Carrick Consulting Group. Today, I'd like to talk to you about artificial intelligence, which has been getting a lot of media coverage recently. For example, researchers at the University of Texas conducted a really cool study. They were able to interpret brain waves to extract strings of text and even chunks of thoughts from their subjects. By collecting enough sample brain waves based on what the subjects were focusing on, researchers were able to accurately predict the subject's thoughts by analyzing their brain waves. This study is just one of the incredible ways that AI continues to propel us into the future. The concept of AI isn't as modern as we might think. In fact, the idea can be traced back to ancient times. For instance, take the tale of Talos, the bronze automaton of Greek mythology. This narrative was found as early as 400 BC and is often seen as a precursor to the ideas of AI and robotics. Another example I can point to is Aristotle, as his work significantly contributed to the foundational ideas about reasoning and the nature of life. His logic really showcased a form of algorithmic reasoning that resembles a lot of the algorithms that are used to power today's AI. Now, obviously, that was a long time ago, and we don't have all day, so I think it's really important for me to skip past a few things, but acknowledge that AI has really been a giant collaborative effort. Unfortunately, I don't have the time to go over every large contribution, but I will cover some of the most important ones in this video. That being said, I'll take a pretty large jump over to the 1940s, more specifically 1943. This is where neuropsychologist Warren McClough and mathematician Walter Pitts wrote a paper about how brains might work in a large network. The model included a simple neural network using electrical circuits. Their model didn't necessarily include multiple layers or backpropagation for learning, but it really was a foundational step in understanding how networks of simple computational units can perform logical operations. Our next entry will bring us over to the renowned Dartmouth workshop. Some of the top minds in the AI field came together, such as John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. During this event, the term AI was coined by John McCarthy in 1955. McCarthy defined AI as the science and engineering of making intelligent machines. It was a pivotal moment in the history of AI. In 1965, we start getting closer to how we see AI in today's media. The first chatbot named Eliza was created at MIT by Joseph Weizenbaum. He aimed to highlight the distinction between human conversation and machine conversation. To his surprise, the general public admired how lifelike the conversations were with the machine. The most famous version of the machine mimicked a Rogerian psychotherapist and responded to users with open-ended questions such as, "How does that make you feel? Tell me more about that." Many people attributed human-like feelings to Eliza despite knowing that it was a program. Next, we'll take a step into the 1970s where we can meet the Wabot. This would be the world's first full-scaled humanoid robot. Created by the minds at Waseda University, the Wabot was not just a spectacle, but it was a vision of the future. This robot had the ability to walk, communicate within a 2,000-word vocabulary, and interact with its environment. It embodied some of the aspirations of creating intelligent machines. Its creation marked a significant stride in AI and robotics, laying down a really solid foundational stone that spurred further into innovation in the future. As we delve further into the realm of AI, it's important to acknowledge the first AI winter. It was a period spanning from 1974 to 1980. This era marked a significant downturn in AI research funding and enthusiasm due to unmet expectations and technological limitations. After the first AI winter, the early 1980s ushered in a period of renewed optimism and investments for AI, commonly known as the AI boom. This was driven by the advent of the expert system, which emulated decision-making abilities of human experts. Companies saw huge potential to revolutionize operations and invested heavily in AI. Alongside the companies, government funding also flowed back into AI research, fueling advancements and hope once more. Unfortunately, this boom didn't last as long as initially anticipated. In the late 1980s marked the onset of the second AI winter, a period that reduced funding and interest in AI that lasted until the early 1990s. Similar to the first AI winter, the problems with technological limitations led to a lot of disillusionment around the process. Expert systems, once seen as a large part of AI's commercial success, proved to be too costly and difficult to maintain for the regular consumer. However, this winter led researchers to explore new methods and algorithms, setting the foundation for future breakthroughs. As funding eventually thawed with the rise of the internet and improved computational power, many of the seeds sown during this cold period started to sprout. In 1997, a remarkable event unfolded, as IBM's Deep Blue became the first computer to defeat reigning world champion Garry Kasparov. Deep Blue's victory wasn't just a triumph in a game, it symbolized a significant advancement in AI, showcasing the potential of machine intelligence in complex problem solving. This milestone ignited imaginations and provided a glimpse into the future of AI, bridging the realm of theoretical computing and real-world application. As we transitioned into the early 2000s, lots of developments occurred, setting the foundation for modern AI. Firstly, the onset of big data emerged from the digital transformation, unlocking vast amounts of data crucial for training sophisticated AI models. Secondly, the advancement of GPUs significantly enhanced the computational capacities, enabling the handling of more complex models and data, which significantly enriched machine-human interaction using language. Lastly, the early groundwork for deep learning began, with novel algorithms and techniques being devised, which would later become integral to AI's evolution. These pivotal developments during the early 2000s played a critical role in shaping the AI landscape we see today. The 2010s can be marked as a defining decade in this journey. The inception of deep learning significantly revolutionized image recognition, rendering machines capable of identifying and interpreting visual data with unprecedented accuracy. Concurrently, the advent of transformer architectures, exemplified by BERT and GPT models, reshaped natural language processing, enabling machines to understand and generate human-like text. The decade witnessed rising debates on AI ethics and its social impacts, urging the community to contemplate responsible AI practices. Also in this era, open-source AI frameworks like TensorFlow and PyTorch really democratized AI development, fostering a culture of collaboration and innovation. As we step into the 2020s, the realm of computer vision is witnessing remarkable advancements, enabling machines to interpret the visual world with heightened accuracy. Simultaneously, the field of natural language processing has continued to evolve with the aid of large language models, also known as LLMs. These models are capable of handling a wide variety of tasks. A term that's stirring interest is AGI, or Artificial General Intelligence, envisioning a future where machines can mimic human intelligence across a broad range of tasks and disciplines, bridging the gap between more specialized AI and more generalized adaptable intelligence. To expand on that point, the landscape of reinforcement learning is seeing systems excel without being explicitly programmed, making strides towards more autonomous and adaptive technology. The 2020s are shaping up to be a promising era, where these advancements could potentially redefine the technological landscape and its role in everybody's lives. Looking back, we see a journey from humble beginnings to the powerful AI applications of today, each era marked by key milestones, nudging AI from theoretical to tangible, with every day seemingly bringing us closer to what seemed like science fiction. It's hard to say what the future holds for AI, but I do know I'm very excited to watch that journey unfold. I hope you enjoyed this brief journey through AI's evolution. If you found this video insightful, feel free to share with others. I appreciate your time, and I hope you have a good rest of your day.